China is no longer exploring the moon. China is preparing to own it. In the past 5 years, their robotic probes have uncovered something no other nation has seen: mantle rocks ripped from the deep interior glass-like dust that clings like a living threat, and a rare fusion fuel buried in crystal. These discoveries changed Beijing's strategy overnight. The moon is no longer a symbol. In geopolitics, it is the ultimate high ground, an energy bank, a military asset, and the first territory of a future off-world empire. Because whoever controls the lunar poles controls the entire Earth-Moon economy. So the real question isn't why China is moving so fast, but what they found in the darkness that forced them to. And it begins with a silence that lasted 4 billion years. For most of its history, the moon has known only stagnation. After the final Apollo footprints were stamped into the gray dust in 1972, humanity turned its back. The silence returned deep and absolute. But while the West celebrated a victory of the past, Beijing was calculating the future. Today, the geopolitical landscape of space has shifted violently. The American Artemis program is entangled in indefinite delays and budgetary gridlock. Russia's attempt to reclaim its Soviet glory ended in a crater when the Luna 25 probe lost control and smashed into the surface. In stark contrast, the China National Space Administration has executed a roadmap of terrifying precision. Chang'e 4 to the forbidden far side. Chang'e 5 returning the youngest lava samples ever seen. Chang'e 6 conquering the South Pole Basin. This is not the frantic sprint of the Cold War. It is an industrial siege, a methodical, step-by-step encirclement of the lunar frontier. Why now? Because for the first time, technology has caught up to ambition. The convergence of autonomous robotics, heavy-lift logistics, and resource scarcity on Earth has transformed the moon from a scientific curiosity into a strategic necessity. China recognized this silence not as emptiness, but as opportunity. They understood that the vacuum is not a void to be crossed, but a territory to be mined. But to exploit this world, they first had to understand it. And what their forensic probes found on the surface shattered every assumption we held about our celestial neighbor. The moon, we thought we knew, was a lie of perspective. For millennia, humanity has stared at the man in the moon, the vast dark plains of ancient lava on the near side. But the moon has two faces, and they do not match. While the side facing Earth is scarred with frozen basaltic seas, the far side is a rugged, chaotic highland of light gray crater fields. To understand the true history of this world, you cannot just look at the mask. You must examine the skull beneath. Apollo landed in safe volcanic plains near the equator, akin to visiting a parking lot and claiming to know the geography of a continent. China chose to land where no nation dared, inside the deep wounds of the moon. The target was the South Pole Aitken Basin, a colossal impact crater, nearly 2,500 kilometers wide, roughly the size of India. This is the oldest and deepest scar on the moon, created nearly 4 billion years ago by an impactor so violent it punched 13 kilometers down into the crust. It was here inside the Von Karman crater that the Chang'e 4 mission made history in 2019. For the first time, a rover drove across the far side. What it found was not just surface regolith, but material excavated from the deep lunar mantle, the semi-solid rock layer that separates the crust from the core. This was the forensic evidence astronomers had been chasing for decades, effectively opening a window into the moon's internal organs. As the Chang'e probes began returning samples, the timeline of the moon began to crumble. The accepted theory built on Apollo samples suggested the moon cooled rapidly after its violent formation. But the forensic data from China's robotic fleet tells a different story. Chang'e 5 landing near the Mons Rumker volcano returned the youngest lunar rocks ever found, dating back just 2 billion years. Then came Chang'e 6 in 2024, the first mission to return samples from the far side. It delivered a geological paradox. It uncovered the oldest lunar rock ever recovered, a relic from 4.2 billion years ago, right beside surprisingly young volcanic basalt dated to 2.8 billion years. This anomaly defies the standard Big Splash cooling models. It suggests the moon remained hot, molten, and volcanically active for billions of years, longer than previously believed. It wasn't a dead rock, it was a dying world that refused to go cold. But the most immediate discovery was not about time, it was about texture. When Chinese scientists opened the canisters from the far side, they found the soil was different. It was lighter in color but physically denser, thicker, and stickier than anything brought back by Apollo. This is the glass storm. On the far side, exposed to the raw vacuum without the shielding effects of Earth's magnetotail, the regolith behaves like a micro-razor swarm. These particles are jagged shards of silicate that have never been smoothed by wind or water. Charged by the relentless solar wind, they develop a triboelectric cling, sticking to machinery, clogging joints, and threatening to grind gears to a halt. This sticky dust is not just dirt. It is an environmental antagonist that actively resists human presence. China has mapped the history, and they have identified the enemy. But discovering how the moon was formed is only half the story. The real shock came when China realized what the moon can produce. Because rocks are evidence, but energy is power. To a chemist, the moon is not a desert. It is a frozen ocean of potential energy. For billions of years, the solar wind has bombarded the lunar surface, embedding volatile elements into the crystal lattice of the regolith. China's mission is to unlock this chemical vault. They are not just analyzing the soil, they are learning to transmute it. The first breakthrough in this planetary alchemy was the discovery of a completely new mineral known as Chang'e Y. Identified in the samples returned by Chang'e 5, this transparent colorless crystal, smaller than the width of a human hair, is the geological smoking gun for helium-3. Helium-3 is the holy grail of future energy. Unlike the heavy isotopes used in current nuclear fission, helium-3 offers the potential for clean fusion energy, generating massive power without the dangerous radioactive waste. Because Earth's magnetic field blocks the solar wind, this isotope is virtually non-existent on our planet. But on the moon, it has been accumulating for eons. By mining Chang'e Y, China is effectively harvesting sunlight trapped inside stone, securing a strategic reserve that could power human civilization for centuries. But fusion is a dream for the future. The immediate necessity is water. Chang'e 5 rewrote the rulebook on lunar hydration. Previously, we believed water was trapped only in the shadowed craters of the poles, but Chinese scientists discovered water molecules chemically bonded within a mineral called ULM1, a hydrated salt found near a volcano. This discovery implies that water is not scarce but locked inside the rocks at lower latitudes. It means a lunar base does not need to huddle exclusively in the polar dark. With the right heat application, colonists can liberate water and, by extension, oxygen from the ground beneath their feet. Yet alchemy requires heat and survival requires power. This brings us to the most brutal logistical reality of the moon, the 14-day night. When the sun sets on the moon, it vanishes for 2 weeks. Temperatures plunge to unfathomable lows, and solar panels become useless slabs of glass. Batteries are too heavy to store enough power for such a long darkness. To maintain a permanent presence, China realized they needed a heart that never stops beating. The solution is nuclear. In a strategic alliance that cements the Eastern Bloc's dominance in space, China and Russia have partnered to build a nuclear power plant on the lunar surface. Russia's state-owned Rosatom, the world's largest manufacturer of nuclear reactors, brings the hardware expertise. But operating a reactor in a vacuum presents a unique physics challenge: cooling. On Earth, reactors use water or air to strip away heat. In the vacuum of the moon, there is no air to carry the heat away via convection. The only mechanism left is radiative cooling. The Russian-Chinese design will likely feature massive thermal sails, gigantic radiator panels extending like infrared bat wings into the black sky. These panels must glow red-hot in the dark, radiating waste heat directly into the void of space. This reactor is the keystone of the International Lunar Research Station. It ends the energy crisis of the long lunar night and makes continuous industrial operations possible. In the logic of space conquest, this is the checkmate move. On Earth, nations wage wars for oil pipelines. On the moon, the battle will be for gigawatts. A base that can crack oxygen from stone and harvest fuel from dust becomes independent of Earth. And independence is the ultimate form of sovereignty. Extracting oxygen and helium-3 is one thing, but to use these resources, China must survive the deadliest engineering environment in the solar system. And that requires building something humanity has never attempted before. On Earth, architecture obeys gravity. We build heavy foundations to anchor skyscrapers against the pull of the planet, and we install windows to welcome the sun. On the moon, that logic is a death sentence. To survive here, Chinese engineers have had to unlearn thousands of years of human construction history. They are designing for a world where gravity is weak, the atmosphere is non-existent, and the sun is a deadly source of radiation. The result is a new discipline, xeno-architecture, building for worlds that were never meant for human life. The first rule of lunar construction is in situ resource utilization, the principle of building with the moon's own materials. Shipping concrete or steel from Earth is logistically impossible. It costs thousands of dollars to launch a single kilogram of mass. Therefore, the base must be built from the moon itself. This is the primary mission of Chang'e 8, scheduled for 2028. It will deploy a robotic mason, a 3D printer designed to sinter lunar regolith into interlocking bricks. But simply stacking bricks creates a fatal flaw. In a vacuum, a pressurized habitat wants to explode outward. Rectangular structures common on Earth have weak corners that would burst under the pressure differential. China's solution is the moon pot vessel. Mimicking the biological perfection of an eggshell, this design abandons hard edges for curves. The automated printers will lay down a mixture of heated soil and adhesive in a continuous spiral. The walls are not solid, but cellular, comprising an inner shell, an outer shell, and a triangular rib structure sandwiched in between. This biomimetic geometry provides immense structural integrity without the need for heavy internal liners. It is a habitat that fights the vacuum, not with brute force, but with geometry. 3D printing also allows for verticality. In the low gravity of the moon, 1/6 of Earth's structures can be printed taller and thinner than anything possible at home. The lack of wind load means these towers can stand slender and expose monuments to a new kind of physics. But even the strongest eggshell cannot block everything. The surface of the moon is a shooting gallery for micrometeoroids and is bathed in constant cosmic radiation. For long-term colonization, the safest place to build is not up, but down. China is actively hunting for natural megastructures, lunar lava tubes. Billions of years ago, rivers of molten rock flowed beneath the lunar crust. When the volcanoes died, the lava drained away, leaving behind hollow tunnels of staggering proportions. Because lunar gravity is so weak, the roofs of these caves can span kilometers without collapsing wide enough to house a Manhattan skyscraper on its side. These are the inverted skyscrapers of the future. Chang'e 7, launching in 2026, will carry ground-penetrating radar specifically to map these subterranean voids near the South Pole. Inside a lava tube, the deadly thermal swings of the surface, boiling at 120 degrees Celsius and freezing at 130 degrees Celsius, vanish. The environment stabilizes at a constant, manageable sub-zero temperature. The kilometers of basalt rock overhead provide a shield against radiation far superior to any material humanity could manufacture. In this vision, the lunar surface will remain barren, dotted only with solar farms and landing pads. The true civilization will be troglodytic, thriving in the eternal silence of the underworld, safe within the veins of the dead world. But a fortress means nothing without supply lines, and Beijing knows this. To turn the moon into a province, they need machines capable of delivering an unbroken industrial chain, and they have already built them. To understand China's lunar ambition, you must stop looking at their science experiments and start looking at their heavy industry. Exploration requires curiosity, but occupation requires logistics. A fortress on the moon means nothing if you cannot move mass, people, food, fuel, and machines across the 384,000-kilometer void with the regularity of a shipping lane. To achieve this, Beijing has forged a new triad of machines designed not for flags and footprints, but for routine, heavy-lift access. The backbone of this system is the Long March 10, currently under development for a 2027 test flight. This rocket is a 90-meter-tall industrial workhorse. Unlike the experimental and massive Long March 9, the Long March 10 relies on proven technology, kerosene-fueled YF-100 engines, clustered in a triple-core configuration. Visually and functionally, it mirrors the SpaceX Falcon Heavy, capable of hurling 27 metric tons of payload directly to lunar orbit. But the true strategic value lies in its recoverability. China plans to reuse these boosters, catching them upon return, not with landing legs, but with a system of wire tethers. This is not just about saving money, it is about cadence. A reusable fleet turns a rocket launch from a bespoke event into a scheduled departure. Riding atop this pillar of fire is the Mingzhou spacecraft, also known as the Dream Vessel. Weighing 26 tons, it is the deep space taxi designed to carry a crew of 3 from Earth to lunar orbit. But the most radical departure from history lies in the vehicle that will take them down to the surface. In the 1960s, NASA's Apollo lunar module was nicknamed the Spider, an awkward angular craft built in 2 separate stages. When it lifted off from the moon, only the upper section ascended, leaving the landing legs behind as discarded debris. It was a machine designed for a disposable era, used once and then abandoned. China's lander, the Lanyu, known as Embracing the Moon, belongs to an entirely different breed. It is a beetle. Recent tests reveal a sleek, single-stage vehicle that descends and ascends as one complete unit. It does not leave its landing gear behind. Powered by 4 main engines and a ring of stability thrusters, the Lanyu is designed to land, offload 2 astronauts and a rover, and then lift off entirely intact. This design choice is a massive engineering gamble. It requires hauling the heavy landing gear back into orbit, punishing the fuel margins. But the strategic payout is immense. A single-stage lander is easier to refurbish and reuse. It implies a future where the same vehicle shuttles between the lunar surface and the orbiting station, repeatedly acting as a permanent elevator for the new colony. The flight profile also differs from Apollo. Because the Long March 10 cannot lift everything in one go, the mission requires 2 launches, one for the lander, one for the crew. They will rendezvous in lunar orbit, a complex ballet of docking that allows China to land massive payloads without building a rocket the size of the Saturn V. The deadline for this system is written in stone. China has publicly committed to landing boots on the moon by 2029. This date is not arbitrary. It marks the 80th anniversary of the People's Republic of China. In the world of authoritarian geopolitics, missing such a symbolic deadline is not an option. The engines are being tested, the metal is being cut, and the political will is absolute. But rockets and bases don't win empires. People do. And the harshest barrier China faces is not gravity or vacuum or engineering. It is the human body itself. The steel of the Long March 10 can withstand the vacuum. The composite skin of the Lanyu lander can repel micrometeoroids. But the cargo inside the human crew is made of water carbon and fragile DNA. In the race to colonize the moon, technology is the easy part. The true bottleneck is biology. The moment a taikonaut steps onto the lunar surface, they enter an environment that is actively trying to kill them on a cellular level. The first assassin is invisible. Without the protection of Earth's atmosphere and magnetic shield, the lunar surface is exposed to a constant storm of galactic cosmic rays, high-energy particles traveling at nearly the speed of light. On the moon, radiation levels can spike to 200 times higher than on Earth. These particles act like subatomic bullets, shredding through spacecraft hulls and human flesh alike, unzipping DNA strands and drastically increasing the risk of cancer and neurodegenerative disease. Then there is the gravity. At 1/6 of Earth's pull, the human body begins to dismantle itself. Bones, sensing they no longer need to support weight, stop regenerating. Calcium is leached into the bloodstream and dumped out through urine, a condition known as rapid onset osteopenia. Muscles atrophy and the heart shrinks because it no longer has to pump against strong gravity. A colonist returning to Earth after a year on the moon might find their skeleton too brittle to survive the hug of their own home planet. And finally, there is the air they breathe, or rather the dust that contaminates it. The glass storm outside is not just an engineering nuisance, it is a respiratory hazard. Because lunar dust is never eroded by wind or water, every grain remains microscopically jagged. If inhaled, these particles do not just irritate the lungs, they lacerate the alveoli, causing chronic inflammation and scarring similar to black lung disease. It is called lunar silicosis, and there is no cure. But the assault is not just physical, it is psychological. The moon's rotation creates a day-night cycle that is alien to human evolution. 14 Earth days of blinding, unshielded sunlight, followed by 14 Earth days of absolute darkness. This is the longest night. For 2 weeks, the colony is plunged into a freezing blackness, where temperatures drop to 130 degrees Celsius. The circadian rhythms of the crew, hardwired for a 24-hour cycle, shatter. Sleep becomes difficult. Alertness fades. On the far side, where Earth is never visible in the sky to offer a psychological anchor, the isolation becomes absolute. The mental strain of living in a confined buried canister surrounded by a lethal vacuum and silence is a variable that no wind tunnel or centrifuge can test. Yet this biological gauntlet is the final gatekeeper. If China can engineer a way to overcome the moon's hostility through pharmaceutical shielding, genetic screening, or subterranean habitats, the rest of the solar system becomes reachable. And that is why the true ending of this story is not about the moon at all. For 4.5 billion years, the moon has been a silent witness. It watched the Earth cool, the oceans form, and life crawl from the sea. Through aeons of bombardment and icy stagnation, it remained a ghost world, a silver graveyard orbiting a blue garden. But that silence has ended. In the span of a single decade, the geological timeline of the moon has been violently interrupted. The footprints of the U-2 rovers, the drill sites of Chang'e, and the blueprints for the International Lunar Research Station mark the beginning of a new epoch, the industrial lunar age. The scars of the South Pole Aitken Basin are no longer just geological features. They are construction sites. The gray regolith is no longer just dust. It is the concrete of future cities. What we are witnessing is not merely a space program. It is the annexation of a new world. By mastering the extraction of water, the fusion potential of helium-3, and the architecture of lava tubes, Beijing is treating the moon not as a distant celestial body, but as the eighth continent. It is a territory to be mapped, mined, and militarized. It is an extension of the economy, a high ground for defense, and a launch pad for the rest of the solar system. If the technology holds, and if the human body can endure the exile, the first children born off Earth may look up at the bright blue marble in their sky and call it the Old World. China's rapid ascendancy forces a reckoning for every other nation on Earth. The timeline of conquest is accelerating, and the window of opportunity is closing. The question is no longer who will get there first, but who will be established enough to set the rules when the dust finally settles. China may not just be racing the world, it may be racing history, striving to become humanity's first true off-world civilization. The moon is not humanity's past. It is China's chosen future. And for the rest of humanity, only one question remains: follow or be left behind.